let's make another logic diagram and truth table given this Boolean expression, which is A or B, all inverted. So the expression is x equals A or B, all inverted. So I know that I'm going to need a OR gate because I see the OR here. This is an OR symbol. So I'm going to draw an OR gate. Please always put OR inside your OR gate, or we don't really know which one we're drawing. A would come into the OR gate, B would come into the OR gate. So, but we notice also that this is all inverted. Now, if these were inverted separately, like if it looked like this, then that would be an entirely different thing. These are all inverted. So to get them all inverted, this is implying that we first do the OR operation and then we invert the result. So there's an inverter. So now what we had in here was A or B, and what we have here is the same thing, A or B, but it is inverted from this inverter that we went through. So that's the answer. We could also draw it. It's the same as doing this. Here's a shorthand for inverter. It's just a circle at the end. So that also would be x equals A or B, all inverted. So let's look at the truth table for this. There are only 2 inputs, so there would only be 4 possible combinations of output. Let's look at it at a node, A or B. And then let's look at the final answer, x equals A or B, all inverted. There are 2 inputs, so there's only 4 possible combinations of A, B as inputs. Here, I'm just A or B is just simply a 2-input OR gate where the result is high if one of the inputs is high, or the other input is high, or both of the inputs are high. Otherwise, it's 0. Now I'm focusing just on these 2 columns, and I'm saying that x is the inverted version of this column. So an inverted version of this column means the 0 turns to a 1, the 1 turns to a 0, etc. So the answer, the final output of the truth table is this last column, 1, 0, 0, 0.